get applause. And I wanted it. You want me to do it again, Tejas? OK. Thank you. Thank you. I do drink water like a queen. So hi, yes, I am Jenn Creighton. I do work at Netflix. So sorry if we canceled your favorite show. I really have nothing to do with that. Or maybe I did. You'll never know. I am somewhat active on Twitter, less so these days, I'm not going to lie. If you happen to be on Blue Sky, I'm a little bit more active on Blue Sky. I'm sorry, I don't have invite codes, though. I apologize for that. But if you happen to be on there, those are where you can follow me. Feel free to reach out to me on Twitter or Blue Sky. Come say hi to me after this talk. I really like meeting new people. OK, so as you know, this talk is focused on debugging async JavaScript. And there are various focus areas of this talk. Much like async JavaScript, we're not really going to be going quite in order, but we are going to be hitting on these topics. So why is debugging asynchronous code difficult? I think it's particularly tricky, and there are some reasons for that. What common pitfalls can we avoid when writing async code? That's going to help us avoid bugs in the first place. And then what are some debugging options when something has gone wrong? How can we figure out what the problem is? Now, to kickstart these topics, I am going to be showing some examples of async bugs. If I show you some code and you don't know what the bug is or what the problem is, that is totally OK. All right? I am not quizzing you. This is not a quiz. But some of you are going to know right away, immediately, what the problem is. And if you do, I want you to do something for me. I want you to ask yourself, how do I know that? Not why is this bug happening, but how do you know? And I'm going to come back to this later, I promise. Moving on, though, we're going to get started actually looking at some code. And in this scenario, we are tasked with retrieving a config file and validating a property on that file. And our coworker lets us know that there is a function that we can pull in to retrieve the config. So that's what we do. We import the getConfig function, and we call the function, expecting it to return the config. Except it doesn't. OK. We get undefined. And now what I would do is I would look inside of the getConfig function. I want to see what it does. And no, there is no documentation. So here is the getConfig function. And what we discover is that it takes a function, it reads the config file, receives back some data, which is the config file, and then it calls the function with that data. OK, so this doesn't really work how we expected it. And to be honest, it kind of sucks that you have to pass in a function. So maybe we can modify this to return the config like we expected. To do that, we're going to create a new variable. We're going to assign it to the data, that data to the variable. And then we're going to return it. But when we run this, we still get undefined. Now, this example is very loosely based on something that actually happened to me. And I've changed several of the facts. But I did need to use a function that retrieved a config. And when I ran it the first time, I did get undefined. Now, unlike this example, I knew what caused the bug immediately. And I would not be surprised if you knew immediately what caused the problem. Because again, how did you know that, though? Hold on to that thought. Because in this contrived example, we don't know. OK, we're trying to find out, which means that we need to debug. And when I need to debug, I reach for console.log. OK? Thank you. Yes. Clap for console.log. Console.log has served us well. I love console.log. I think it's great. Like, no shame in console.log. It is a very quick, simple option to get more information and help you debug, right? I am going to show you the debugger in later examples. I love that too. But the debugger is a separate tool, and we choose the tool for the job. That is just as true in debugging as it is in writing code. And for this job, like, console.log is perfect, okay? I want to know more about what's happening in this function. I want to know what is the value of the data when it's received. I want to know what value is assigned to the config variable. And as I do this, I expect the logs to happen in this order. So 1, 2, so the data and then the config. What I get, though, is 2, 1. Right? I get the config, it's undefined, and the data is an empty object, which I expect. The config file is just that. Again, if you don't know why the order is off, that's totally okay. But this is where I would realize that this code is not synchronous. If I didn't know that before, now I do. How do I know that? I've seen this before. I have found that most of the time, the answer to that question really boils down to that. I've seen it before, or I've worked with it before. And if you knew, that's likely the answer that you came up with. If you've worked with Node to read a file, then you know that read file is asynchronous. So in the real version this example is based on, when I called getConfig and received undefined, that's how I knew what happened. I've worked with Node before. I realized the function used read file and that I had mistaken an asynchronous function for a synchronous one. Or maybe you've worked with asynchronous callbacks before. And I say asynchronous callbacks because not all callbacks are, but that could have been the information that clued you in. Or maybe you didn't know until you saw this. This is a really big clue. It is something that I have internalized through years of debugging. An unexpected order means some code somewhere is asynchronous. And knowing that is really half the debugging battle, which is why debugging asynchronous code is tricky. You might not even know the code is asynchronous. You might write code like this, not knowing that read file is asynchronous. Which, let's step through this function so that we are all on the same page about what is happening here. First, the config variable is created. Then we call read file, and since that is an asynchronous function, it starts, but it doesn't block the following line from executing. And that next line is actually returning the config variable, which was never set, and so its value is undefined. Meanwhile, read file actually does receive the file, calls the callback, where the data is assigned to the config variable. But it doesn't matter because the outer function returned in the previous step. And that's how we get an undefined config, even though the data is read. So the data exists, but we're not waiting for that data. And that is the bug. And notice that at no point are we receiving an error message. Why would we? This code is incorrect, but valid. So bugs can be broken down into like a few different categories. And some of them are more difficult than others. Syntax errors are really quick fixes. Runtime errors might not be quick to fix, but there are at least errors to help guide you. But this, writing code that is valid but incorrect, that's the most difficult category to debug. Here's another example. We're going to undo our past work on the getConfig function, and instead of attempting to return the config, we're going to wrap read file in a promise. A quick note that yes, we could use read file sync, which is the synchronous version of read file, or in newer versions of Node, a promise-fied read file exists. But let's say we can't use the sync version, and we're stuck on an earlier version of Node.js. It happens. So we're going to have to do the legwork ourselves. And that legwork includes returning a new promise and resolving that when we receive the data. So it's really not too much legwork. And then we're going to run this, right? Let's see if this works. We're going to call getConfig and the attach.then handler, which for now will just log the config to the console. And when we run this the first time, we see Yeah, undefined. Still. OK. But this should work, right? This should work. OK, again, console.log, my trusty friend. We're going to log out that data. And the data is undefined. OK. Knowing this, I'm going to check that the config file exists. And yeah, it doesn't. Turns out when I undid the previous changes, I accidentally removed the config file too. That's actually happened to me before. It's obnoxious. But did we get an error? No. So let's log out the error. Oh, no, we did get an error. We did. OK, so this makes sense, right? No file or directory. Which I want to note, by the way, like that's not the bug here, okay? The missing config file is not the bug. The bug is the silent error. When I wrote that promise, I made a really classic mistake. The promise resolves with the data, but it doesn't reject. So when read file can't find the file, it returns an error. But I don't know that. No one knows that. It's been silenced. And silent errors are really the worst. You know, something has gone wrong, but no one knows. And these are super common in async JavaScript because, again, code that is valid, right? It's going to work. It's going to run, but it only works as long as there are no errors here. And knowing this, let's fix our promise so that the error actually is going to surface. We're going to need the reject function. And we're going to use it in an if-else to decide when to resolve and when to reject. If there's an error, we call the reject with the error itself. Else, we resolve the data. Let's see if this works. We're going to call getConfig again. But instead of a .then, we're going to add a .catch, which will catch the error, allowing us to log a more helpful message to the console. Let's run this. Yes. OK, great. The promise is rejecting, we catch it, we log the error message, this looks good. So always reject. It is a best practice, follow it, it will make debugging easier. But I should note that there are so many ways for error handling to go wrong in asynchronous JavaScript. And these bugs, they often fall into that valid but incorrect category. Let's look at another fun/infuriating example. Let's say we're building an application where a user can RSVP for an event. I don't know, say maybe a JavaScript conference in Belgium. I don't know. That's what this function RSVP does, OK? It also returns a promise, and it's handling errors with .catch. And our current task is to add some UI that shows a schedule of the user's various events. So let's add a .then handler so that once the RSVP resolves, we update the UI. Now, this is and is not a good idea because we do need to do something like this. But written like this, we've created a bug. Unlike the last time, though, I am not going to reach for good old console.log. I still love it, but I think there is a better tool for this job, the debugger. And I really love the debugger for async code because it helps offload the mental weight of thinking async. There is this extra mental tax when we write or debug async code. So as humans, we are really inclined towards events that happen one after the other. So A, then B, then C. A, then B starts, then C, then B ends. It's like mind-bending, right? And with logging, you're actually still doing those mental gymnastics while keeping track of what got logged when and where. And at some point, the mental tax is too high. It is no longer effective. And this is where the debugger can help. Unlike logging, the debugger can pause execution. And that allows you to inspect the state of the application at a certain point. And then from that point, the debugger can step through your code, run it line by line. So this really allows you to step through asynchronous code as if it were synchronous. Let's take a look at this in the Chrome developer tools. And first, I'm going to show you the case where this works. Everything's fine, because there is a case where the code that I wrote, you won't notice the bug. Under the Sources tab, I've selected the file where the code runs. I'm going to set a breakpoint on line 15 where the RSVP function is called. Okay, so I've set the breakpoint. I'm going to click to register the event. Now the debugger is enacted, it's paused the code, and I'm going to start stepping over the functions. And that will call the function without actually stepping inside of it. And so I get to the RSVP event, I can look at the call stack, and I can see that the promise.then was actually called. Now I'm actually going to step into the function, and I just want to see oh, it was called with the right ID. Yes, it was. Great. And then I'm just going to step through a few more times until the program is done running, and you can see the UI update. OK, so that is the case where everything works as expected. I'm going to break this now. And I've modified the code so that the promise returned from the RSVP function is going to reject. So what I expect is that the .catch runs, but the .then is ignored. So we're using the same breakpoint. I'm hitting the button again. It's pausing. I'm stepping over the functions. They're running so I can see what happens. We hit RSVP. This time it's rejecting. And I can see, yes, the .catch was called. That's correct. Keep stepping through. Now. So now we're in that add event to calendar. If you look in the call stack, you're going to see actually that the promise.then was called. So you can see the UI changing. Something went wrong. But the event still got added. So something went wrong, but the event still got added. So that's the bug. This is another example of valid but incorrect. And look, it is not unreasonable to think that since .catch is ignored when a promise resolves, that .then is also ignored when a promise rejects. And that is true. But it's also true that the order matters. And so .thens after a .catch will still execute. And to fix this, we just need to move the .catch to the end. And now, when the promise rejects, .then will be ignored. And this is just one example, right? I really don't have time in this talk to cover all the options and intricacies of error handling in promises or async await, because error handling in async await is different. Async await is this really strange but lovely addition to asynchronous JavaScript. And it can make writing async code much cleaner, much clearer, but it can also introduce some issues. For example, here is some promise-based code, and we might want to convert this to async await. And when we do so, it might look like this: an async function awaiting promise 1 and 2. The problem is that the promise-based code and our async await refactor, they're not equivalent. It actually might be fine, but we've taken code that didn't block. The promises in the previous example actually ran in parallel, and we've modified it to block. So await blocks until the promise resolves or rejects. And this refactor might have some unintended consequences. Promises and async await have some really core differences, but I think this is actually the biggest one. Promises are non-blocking. Async await can be both blocking with await or non-blocking. So await is not required to run a promise in an async function. And also, async functions return promises. So this intermingling of async versus sync is why I call async await strange. It's that same mental tax that I talked about earlier, thinking async, and it's a lot. It leads to something that I call what does what and when and where. What this means is that you need to be familiar with all the ins and outs of different async structures in JavaScript. Promises, async await, callbacks, set timeout. And keeping this all in your brain all the time is impossible. Mistakes are bound to happen. Here's another favorite of mine. I've written a very tiny little application that fetches some posts and just lists their titles. Except I'm not seeing the data actually show up in the UI. First thing, I'm going to check the network tab. And yes, the data is coming back. So something is wrong in my code. We're going to set a breakpoint. Because I know that the data is coming back, I'm going to pause execution on line 12. I want to make sure that this was set properly. So execution paused, and I'm going to do that, and now execution paused. I can see fetch post. Results is undefined, and I expect that right now, because I actually haven't run fetch post. When I step over, now it runs. Now I can check the results of check what results is. And I can see that it's a promise. So I've done something sort of silly here. Async functions return promises. And sometimes when I'm working with async await, I get so used to the format inside the async functions where you can treat promises like they're synchronous that the wires just get crossed. And I forget to switch back into promise mode when calling the function. And this really drives me up a wall. So I'm going to fix this by calling fetch post, which returns a promise, and attaching a .then, where I will set the post, and now we're good. But as I said, I've made this mistake more than once, and it's not because I don't know that async functions return promises. But again, this is just a lot to keep in your head at once. And the good news is that I'm actually able to debug this fairly quickly. If I didn't know why this had happened, if I hadn't experienced it before, it might be more difficult to debug. Which brings me to the one debugging tool I haven't talked about yet, and it is the best one. But no, it is not TypeScript or a linter or tests, even though those are all very helpful. Your best debugging tool is knowing something well. And knowing something well cannot be about memorizing the spec. Knowing something well is really about experience. Going back to the start of this talk, the question of how do I know that, I said the answer is often comes down to experience, right? And I want to add on to that. Because going a step further, that experience might be I've worked with Node and I know read file is async. Or it might be these logs aren't in the order I expected. Now that first one, I know read file is async, that is just straight knowledge. Still important in debugging. But that second one, how do you build up knowledge like that? That's not in the spec or the documentation. That is really hard-earned knowledge from seeing things go wrong. And as you go along in your career, as you debug, you will naturally start to build up that knowledge. But if you are struggling with a particular concept, like say debugging async JavaScript, I suggest be the bad dog. Okay, first, on a personal level, I believe all dogs are good dogs. Okay? We all agree? Great. But this concept was introduced to me by a yoga instructor. So she wanted to teach us how to do the pose properly, and to do that, she would teach us once with the correct alignment, and then she would ask us to be the bad dog, or do the pose with an incorrect alignment. Am I perfect at yoga? No. But I do know what it feels like when the pose is off now. That taught me what it felt like when the pose was incorrect. And I can now adjust whenever I feel that something isn't quite where the alignment should be. And I get that same value when I apply this to code. I have struggled with async JavaScript before, and I realized that all of the tutorials that I was reading weren't really helping because they weren't really teaching me what things look like when they go wrong. So if you're struggling, or you want to learn something really well, be the bad dog. Learn the ways it can go wrong and what those look like. You will still make mistakes, and there will still be bugs. But it will be easier to fix those mistakes and find those bugs. And isn't that what we all want? That was a lot. Thank you for listening. Thank you for being here.